Math is often called the great unifier. It is the shared code behind everything from global trade to the engineering of massive skyscrapers. Standard symbols and numbers bypass cultural boundaries, providing a shared cognitive framework that unites human effort across the globe. But consider a highly intelligent, capable child, someone who easily reads chapter books, yet feels completely paralyzed when faced with a simple problem like 2 plus 3. For this child, the foundational logic of the modern world is incomprehensible, locking them out of the universal conversation. This specific barrier is called dyscalculia. It targets the brain's ability to process quantities and mathematical symbols. The contrast is often startling. A student can display high literacy in standard reading while remaining unable to decode basic arithmetic. If mathematics is truly a universal language, why does an otherwise healthy, intelligent brain actively reject it? The friction stems directly from the format of the language being forced into the brain's processing centers. A groundbreaking 2026 brain scan study has finally moved the focus away from classroom failure and into neurological reality. Researchers discovered that children who struggle with math process numerical inputs differently at a biological level. The study compared two inputs: abstract symbols and visual quantities, like these dots. When viewing dots, scans of these messy math brains show intense neurological engagement, but processing severely drops off when forced to look at abstract written numbers. These neurodivergent students are wired for a visual mathematical dialect rather than the standard symbolic one. Dyscalculia functions as a translation error between the brain and the curriculum. The student perfectly understands the real-world concept of quantity, but the abstract written symbol completely fails to compute. Because modern education operates almost exclusively in that symbolic code, it ignores the brain's native visual dialect. As long as the educational software refuses to translate into the brain's native hardware, the student remains locked out of understanding. Neurological proof of these different dialects forces education systems to make a structural choice. One proposed path involves abolishing standardized math tests to allow for individualized learning. Prioritizing a child's native dialect using dots and visual aids aims to maximize their individual cognitive potential. The alternative is to maintain one single standard mathematical language, despite the friction it causes for many students. Society relies on this shared symbolic code to build infrastructure, manage economies, and share complex ideas across the globe. This creates a clash between honoring individual biological reality and maintaining collective societal efficiency. The 2026 MRI data has triggered a shift in how we view mathematical ability. These messy math brains provide critical evidence of human cognitive diversity. The next challenge is discovering how to accommodate multiple mathematical dialects without losing the shared foundation of human progress. We must decide if math remains a rigid law or if it can evolve for minds that see the universe differently.